Hello everyone, it's Animation4. Welcome back to some more Omnifactory. I've been doing a lot of stuff. We're ready to make some big progress today, I hope. It's gonna be real expensive though. So, to get started with, I have a little setup over here. A vacuum freezer running on IV, which is a lot. And a fancy little thing here. Essentially, this is... Oh, I didn't actually do the thing. This is going to... Wow, okay. Take a draconium wire, a nether star, and make, because I have already tested this, a superconductor wire. So you take the draconium wire, you melt down the nether star into a fluid, and you put them in a vacuum freezer, and that gives you a superconductor wire. I will show that real quick. So the nether star should end up in here. Or not, because I need to send this to a chest, don't I? Yeah. Right. It likes to actually be connected to things. Okay, I got this. Take this, put this here. I think that's facing up. It's probably not, though. Yeah, it's not facing up. Face this up. And put this back. And then... grab a chest. Put the chest here. Right. And it should also definitely be inserting. Then I tell this to extract. It's got that. As you see, I'm very prepared for this. Nether star goes in here, gets melted down, the fluid comes up into here. The whole thing gets vacuum freezed. It's pretty quick, and you saw the wire go out. Let's just make like... I don't know, let's choose a random number. Let's choose 14. Let's make 14 of them. So it takes 14 nether stars. It's got to send the draconium through wire mills, which is pretty straightforward. I only used a basic fluid extractor, but it actually will melt them down faster than this will process them. So that's why. There's no reason to upgrade that at all, unless we upgrade the vacuum freezer. This will finish well before it needs to. And that's it. It's not super fast, but it's fast enough that it gets done. And we have nether stars auto-crafted. We have some draconium. I need more draconium dust, but we can auto-craft the ingots. So that's it. I'm gonna wait for that to finish so I could do the next thing I was gonna do. Yeah, 6 more. 5 more. But yes, I was looking at the quest book here, and I think the only way we can actually go from here is to fusion reacting. I think the only thing we actually have to do here is europium. Everything I need to do seems to be caught on europium. We could go further and get the Mark III and get neutronium from this, like go the pure fusion reactor route. But we can also get neutronium from the tier 8 microminer, which I feel like we're closer to because we already have the projector set up. So I think we're just going to do this and then come down here and do that way. Can we actually do this yet? I feel like there's some reason I couldn't do this yet. Maybe not. All right, I've stalled long enough. The wires are done. So I needed to do this so we could get the 8 2x wires and throw them in the assembly machine here and get a superconducting coil block. And that's a quest. And that's a quest. I need 16 of them. Okay. I don't actually plan on putting this in a blast furnace yet. But I need 16 of them, which shouldn't be an issue. like, it's 16 per block. So 16 times 16 would be 256, but I already did 16 of them. So 240 or 16 times 15? Is that a doable thing I can do? I have to craft 157 nether stars. But, you know, it's doable. So do it. It's going to take a little bit of time, though. That's going to take forever. Next on the list of things that I've been working on, we can upgrade the Empower to the auto-crafted version, hopefully. Haven't tested this. This could just not be how it works. But I made a combination package crafter. And I made another packager and unpackager because I think we need those. Like I said, I did not test this at all. Unpackager, packager. And I think these need the pedestals. The marked pedestals. That's the quest. Can I just like place them down like that? Or do I actually need to do something about it? I really don't know how this works. It didn't really explain it much in here. The marked pedestals can be placed freely within 3 blocks distance of the crafting block as long as they're in the same eye level. So I just drop them down. And okay. Is there anything I need to empower? The big thing I think we're going to need is the palace crystal blocks. So, the component. I don't feel like making this right now. We have it down. I'll try to figure out if this is actually correct later. Oh, I just realized I didn't show something yet. So I just made a bunch of nether stars, and that takes this stuff, luminescence. I made a luminescence maker. You put an apatite, and you get luminescence and hydrochloric acid out of it. Over here, I just have a mixer to make energetic blend, and 2 chemical reactors for sulfuric acid. Apatite, sulfuric acid, and water becomes phosphoric acid, which goes into here with energetic blend and some aluminum, makes luminescence. One apatite becomes like 6 luminescence in the end, so it's pretty cheap now. And I just like set it and it just goes. We had about 4,000 before I just made all those nether stars, so we do go through it quite a bit. It also the block also glows. I just realized that's pretty cool. We also get some hydrochloric acid, so I guess like there's chlorine in that, which I use for a lot of stuff. That's useful. This is still going. Huh. There is all our superconductor wire. I know we need a ton of superconducting coil blocks for the fusion reactor. And the only thing this would get us in a blast furnace is dark solarium and these quantum fluxed eternium heavy platings, which are used for the tier 9 miner, which we're still 2 away from now. So we don't have to worry about that. Dark solarium, I guess, is good. But we don't really need it for anything right now. We need it to make the exotic materials catalyst, which is used for the motivodium. But I don't plan on doing that right now. So we're going to just not. And instead throw these in here and get our superconducting coil blocks, all 16 of them, and hopefully use them to make a fission controller. That's the quest. All right. Let's see how awful this is. 32. 80 LUV machine casings. Each of these is 8 lumium. That's 640 lumium right here. We need another same amount of superconducting coil blocks I just made. So I'm going to get those going with 256 wires, which we have the stuff for. It's got to make 128 draconium for it. But we have the stuff for it. And let's look at the rest of this. So 80 LUV machine casings is a bunch of lumium. It's 640. I just made a bunch of lumium up to 503. I made 256 of it. And to do that, I actually upgraded the blast furnace to ZPM, And that actually is like all the power we generate. If I run the blast furnace, essentially every bit of power we're generating gets consumed. So yeah, don't run this forever. Maybe not for 256. Let's look at some other stuff. Nice cheap hatches here, and then some 16 more hatches for that. Okay, I'm gonna read through this real quick. All right, we need 768 lumium, which is how many stacks? 12 stacks. Not aluminum. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All these get compressed down and made in... Why am I doing it this way? I have a thing to do this. So I don't have to, run around. This one, right? 96. Actually, wait. No. I want casings, right? Or is it hulls? Yeah, I want casings. It would have done too much crafting. 96 of these. There we go. 768 lumium. Go. Do the thing. They upgraded to HV compressors at some point, so this should be not the worst thing ever. It'll still definitely take some time. And that's like all my lumium. There we go. A stack and a half of LUV machine casings. So I read through this, and essentially, when you look at the recipe for this, it's this big old circle. And they have lots of these hatches everywhere. The hatches are optional. You could choose hatches or more of the casings. The hatches, though, are much cheaper than the casings. We're going to do all the hatches when possible. It does recommend, well, actually, it does pretty much require all the energy input hatches, because that is the internal storage buffer. And when you look at these recipes, the energy to start is what has to be in that internal storage buffer. So we're going to have all those. And those are all the energy input hatches here. We need 16 of them using these casings. So make the hull, make 16 of these. It's just going to make the vanadium gallium cables. In the meantime, 2 fluid input and 1 fluid output hatch. But we have to multiply that by like a bunch. Is 2 per side, so 8. I don't think there are any in the middle. There are some in the middle. This is really hard to tell what's going on here. So you got input hatches on the bottom, so 8 input hatches there. Output, so 8 here. Then in the center of the ring, I'm trying to tell, you got an output, and 2 more energy inputs. So that's 16 outputs. And then another 8 inputs. So 16 inputs, 16 outputs is what it seems like. And they're just going to be there to take up space, so I don't have to make as many LEV machine casings. Yeah, but I don't have auto-crafted that. The ultra low voltage, I don't have that crafted. So I gotta do those manually, but that's quite all right. Just a bunch of iron plates. I think that'll do it. Got 16 of each. The 30 of these. The hulls become energy input hatches. So we need some vanadium gallium, specifically 16. And then we can finally take a look at the actual fusion reactor controller block, which is 32 HPICs. Definitely don't have 32. 23. So I'll have to make some more of those. But we have the indium now, so it's not that bad. 32 superconductor wires. I should tell that to get started. Those take a bit. Then we have 2 IV field generators. Pretty straightforward. A fusion coil block, which... So I haven't actually made one of these, but we're going to have to make a bunch of them at some point. It's a superconducting coil block, 2 MV reactors, subcircuits, and 2 neutron reflectors. The neutron reflectors being half a stack of beryllium, 4 tungsten carbide, and a reinforced iridium alloy in tin, specifically tin. Okay. Not that bad. I don't think I have, like, a ton of beryllium. I don't have any beryllium. Let's just, like, get 2 of these going. There you go, I got some beryllium. So each of these requires 4608 tin, which is half a stack of tin ingots. So a full stack will give us both. And I don't have any assemblers that don't have soldering alloy in them. For the tin. What? Beryllium, reinforced alloy. Beryllium, alloy. Tin alloy. Oh, not tin. Okay. I'm just gonna ignore this. What tin? Then we can do the thing. Okay. So tin alloy, not tin. That's fine. Still takes a bit of time here. There we go. There's 1 neutron reflector. There's 2. I need MV field generators. 2 of these. Pretty straightforward. And that should be all I need. I need the 32 superconductor, but I also need another 16 for the block that we're about to make. Take these. Come over here, make another superconductor block, because, you know, you can never have enough of those. Then I need to be back down there. We should just be able to do that. Interesting choice of circuits, but there we go. Get the fusion coil block. 2 things left: a nether star plate and a plutonium-241 plate. Luckily, it does make the ingots. We have some of these ingots, so it should just be one of these. And for the nether star, but wait, did I not tell it to make? I just used the nether stars. I told it to make 9 nether stars, and then it just used them to make the superconductor wire. But once that's done, we would throw a nether star block into a cutter. Once it's, you know, done with the nether stars. Which it's pretty fast at, actually. 4, 6. 1 more. There we go. Get a block. Got the block. Throw it in the cutting machine. Nether star plates. Just need 1. Alright, so let's start making sure I can compile everything I need. So we got these 2. We got the fusion coil block. Need 2 IV field generators. 2 of these. Need the improved nether star, which I think is radon. No. Improved. It's quantum star. Quantum stars are chemical bath of 2 radon. Okay. Grab some of this. Alright, the last thing we need is tier 7 circuits. 4 of them. It has them in different slots here, which is kind of weird because they stack. I might put them in manually just to make sure they're in different slots. I'll try putting them all together the first time, but they may have to go in separately. These are still a pain to make, though. We gotta do 4 of them. I think that's everything. Got 6 things and 4 circuits. Yeah. Gonna do all these in. Will be put in individual slots. Spread out. If I put all 4 circuits in one, it takes it. All right, cool. Do not have to, like, spread them out. That should be it. I think that's everything we need. And now the hard part, finding out where the heck we put this thing. It's a big old donut. Where do you put a donut? Huh? That looked like it worked. There we go. We have our floating donut. I need to put some supports to make it look like it's not just entirely floating. Even though it is entirely just floating. You know. Now it's not. Now it's hung. It's hung from the ceiling because I don't have the floor space to put it anywhere else. I mean, that looks kind of cool. I have access to, you know, some of the faces and stuff. I want some cables to it. This thing takes a freaking lot of power. Oops, I broke it. There you go. You can tell it worked because it's all like blue and stripy now. I have a spare casing. So the goal is to make europium. It's needed for making things into conic evolution and wetware processor arrays. So we need neodymium and hydrogen. So both pretty simple. And that's really the only thing I should have to make with this. So to produce 16 millibuckets, which is not a lot, it consumes 1.5 million EU right off the start. Each of these can hold 500K, so that shouldn't be an issue. Then while running, it consumes 1.5 million EU per total, so 24,576 per tick. That's actually not that much. You gotta quadruple it for RF, so it's about 100K RF per tick. But it really shouldn't be an issue. I'm gonna run this off Signalum. And, you know, just like, wait. How do I power it? These are the input hatches. Where's the... Oh, right. They're frickin'... that's awful. They are... What's the term? It's Greg Tech. I gotta use the CEFs. I gotta use CEFs for this. Can I actually wrench these while this is here? I can't. Okay, we're gonna turn all these to upwards. I think it's just gonna look nice. Oops. These are for output notches. I don't care about these. All the energy inputs we're gonna turn upwards. And really for this first one, we should only need like 3 of these. So the buffer can be filled. Yeah, 3 of these can hold 1.5 million. But I'm gonna plug them all in anyway, because why not? Alright, we are ready to power up the donut. I'm doing something a little different with the cables here. I'm using superconductor wire because It's either this or each of these cables costs 2 signalum. We're running LUV, signalum's LUV. Signalum is LUV with 0 loss per block. But 2 signalum per, I'd be spending 72 signalum to get this thing up and running. Instead, we just got 36 superconductor wires. I wanted to do superconductor cables, but apparently they are uncraftable. So we got to use the bare wires. They work, but if there's power running through this and I touch it, that's 32,000 volts, and that's death because they are not insulated. So a little risky. I put some glass here so I can't like bump into it like this. I'd have to be like at a very specific height to get in here to bump the inside. From the outside, just, you know, don't be dumb. I'll probably be dumb at least once. We're going to stay a little bit away from this and do that. And we have power coming in. If I now touch those, we get zapped. I did test it in creative. You do get zapped. And we now have power. It says 1.6 million EU, despite each of these saying 500k. So I'm not sure what that's about. Regardless, once I sleep, so we have actual power generation coming in, we should be good to go. And we'll try to make some of whatever the thing we're going to make is. I forget what it's called already. Europium. So you get it with neodymium and hydrogen. 16 to, or 1 to 3. 16 neodymium per. So a neodymium ingot and a bunch of hydrogen. What I'm going to do, I'm just going to get a small tank, fill it up with hydrogen. I'm going to get some neodymium. Hopefully we can do dust. Maybe 4. Just to see if this is working. See if I can fluid extract the dust. Nope. Melt it. Okay. You gotta blast furnace it. That's fine. Get the fluid. Let's see if this will work here. So we do have to do this like a bunch of times. This is 576 neodymium, and you craft these in batches of 16. So it's like 16 is about like a nugget. Not a lot. Yeah, so you're gonna have to do this a bunch. You know, input hatch, neodymium, input hatch, hydrogen. It's going. It's just doing the thing. Wow, okay. How is power? Power's fine down here. Up on top, we're midday. And we're maintaining. We're maintaining power just fine. Yeah, it's churning away. I think it's all going to this output hatch. There's a bunch of output hatches around this thing. So, yeah, safe. I guess it's just choosing to go to this one. That's fine. I actually preferred just one output. Cool. Grab this, except I can't because it uses this thing. How do I want to get the fluid out of this? I'm gonna do it like in a cool way. You see I'm like suspended this thing from the ceiling. I just want to like run a pipe to the ground, right? I'll do something like this. It's gonna take a little while. Boop. There we go. 576 europium. Grab an ingot mold here. Turn this off. There we go. We got the europium. And now, fusion crafting. Not fusion reacting, fusion crafting. But turns out making a donut like this takes a really long time. So I'm going to be calling the episode here. Thanks so much for watching. Next time we're going to get into fusion crafting. We have all the stuff for it. I don't know if we have the power for it, honestly. But hopefully, we'll find out. Anyway, thanks for watching. See you next time. Bye-bye.